This video will show advanced techniques for using the SCADAPack x70 Smart RTU with the Realflo flow computer. We will look at how to view flow computer registers as objects in the object browser, how to use flow computer objects in a logic program, and how to use alert notifications to do simple control actions, such as a well shut-in. To demonstrate how flow computer registers can be viewed as objects in the object browser, I'm going to begin my first example with choosing objects for my process inputs instead of using the MVT sensor for these inputs. But first, let's look at a comparison of the input type options for the process inputs by comparing the SCADAPack x70 to the input options provided for a SCADAPack 300 series. Well, there's my MVT sensor, but there's these four other options. Well, each one of these is in fact a format for the Modbus register option. And here's where you would enter the register. So each one of these is just a format of a different type of Modbus register. So there really are only two input type options for the process inputs on a SCADAPack 300. There's the MVT sensor, and then there's Modbus, depending on the format you choose. So when would I want to select a Modbus register as the input type? Well, perhaps you want to test the process inputs by writing test values to a Modbus register. Or the process inputs actually come from analog inputs. Or the process inputs are determined by the RTU's logic program, for example, by polling some other Modbus sensor type. In each of these three cases, the value is placed in a Modbus register. For the SCADAPack x70, the Modbus register input type is replaced by the database object input type. And this input type is selected for the same reasons as the Modbus register. When testing process inputs, by writing test values into an object, or when the process inputs come from analog inputs. And finally, when the process inputs are determined by the RTU's logic program, for example, polling some other Modbus sensor type. In each of the three cases, the resulting value is placed in an object. Let's change my controller type back to 470. And now for our process inputs, let's select database object. Now, this is just a suggestion of the object name. I haven't created the object yet in Remote Connect, so I can call it anything I want. I'm just going to call it DP for differential pressure. I'm going to scale it from 0 to 300 inches of water. Now, there's no actual scaling here. It's really just selecting what will be the engineering value range. So before I move on to the next, let's create that same object in Remote Connect now. Add object, DP, and I'm going to put it in a convenient object group, flow run 1, and we'll see where that applies later. The only other thing I want to do is give it basic scaling for the range of 0 to 300 inches of water. So these do have to agree between Realflo and the object definition so that their engineering values are in the same range. For static pressure, database object, and I'll just call it SP. Give it a larger range. Now I can select that object grouping I've already created, and for the scaling, we'll make it the same as what we selected in Realflo. And for temperature, just change the object name to temp, and we'll use this range -40 to 200. There, now I can write that to my controller. I'll apply the changes, go online, and write the configuration. Now I'd like to look at those objects in an object browser. Call it Flow Run 1, and I will add all the objects in that convenient group I already created, Flow Run 1. I'll change their display format to real. And apply that. So if I was to observe these objects online, I go to my browser in the Online Diagnostics tab and refresh, for example, once every second. So these are new objects, so we expect them to have basically values of 0. So if I wanted to write some test values, I could do that now. I'll take it out of auto refresh, and I'll give them some starting values. For DP, static pressure, and then I can select and write all values. Now with some reasonable values to test, let's go to Realflo and see if these are actually applied now that we've selected the objects in our configuration. Well, there's one last step in Realflo. We've selected the objects in the configuration. We need to write the configuration now. Now, I do know that I still have my MVT in the configuration, even though it's not being used by this flow run, but we'll just keep it for now. If I had not created those objects, or if I had renamed them differently, then the values shown here for Realflo would simply show up as 0. But we expect to see actually it looks like we've already received our current values, 89.7, 2000, there we are. So now I can change the values from the object browser if I wish. And write all. So I'm viewing my objects here in an object browser, and the same values are being used in Realflo 35.6. There we go, it's updated as we expected. After testing the objects with these preset values, if the process inputs came from sensors wired to analog inputs, then now would be when you would associate our objects with physical analog input channels. Let's do that now. Selecting physical I/O, and if we choose our first analog input channel, I can clear this object associated with it and instead choose my new object. We could have this for DP, for example. And the same would be for static pressure. And temperature. Now, if ever a channel was damaged in the future, I could easily reassign it to another working channel without having to change the configuration or my program logic if it uses these objects in that program. Apply the change and write this to my controller. Looking with my object browser, I can now change my process inputs by varying the values at the analog inputs. Now to look at these objects in a simple logic program. We're going to use static pressure and its alert notifications to execute a well shut-in. Let's begin first by looking at the configuration for these objects. So most of the default objects already have a logic variable type associated with it. Our three process inputs still need to have a logic variable type selected. So for differential pressure, I'm going to select real. For static pressure, I'm going to select advanced analog, and you'll see in a moment why. And for temperature, real. Apply the changes and write them to my controller. Opening the logic editor, under derived variables, I see all my objects here. Here's my DP, SP, and temperature. I'm going to select all three of these and put them in an animation table. And if I go online, I can view their current values. So for DP, I see its current value here and object quality. And for temperature, the same thing. But for static pressure, I've selected advanced analog so that I can look at its engineering value as well as the 8 states for 8 limits. If we were to configure a low limit for, say, 200 psi, we could trigger a well shut-in based on the state of this alarm. Let's do that now. Under Alert Notifications, I'll select my first level for low limit and choose the value of 200 psi. Apply and write the change. I'm going to close my animation table, go online again, and for static pressure now, we can see our value as well as the limit here. So if I bring my value below 200, there, the limit comes on. Now we don't want to have it come on immediately as soon as it goes above 200, so we should set a high limit for when the pressure returns to a normal level. I'll choose 800 psi. Apply and write that change. Now if we look at the low limit and the high limit and keep an eye on our pressure, as it goes low, we see the low limit come on, and when it resumes above 800, we see the high limit come on and stay on as it increases. So how could I use this to shut in our well? Well, let's choose the digital output 1 as our sales valve control for that well. I'll rename that object now. And apply the change. We should see this right away in our logic editor. There it is here. So to create some logic for this, I'm going to create a logic section of type function block diagram, and I'll call it well control. And what I want to use to control the digital output for my sales valve is I'll insert a block called reset. And this block, if we look at the help on this type, it will set the Boolean output depending on a set input or reset input. So we could use our high level here and our low level state here. And then we'll connect our well output on the output. So to turn off my well, static pressure, and it's the low state. The well we're changing its current value. And finally, to turn the well back on, we'll choose the static pressure, and it was our level 1 high. I'm going to disconnect, build all, and write the configuration and the program to my controller. Going online, I would like to look at the animation table value and my logic at the same time. Here's my static pressure. So as I go below the limit of 200, I see the wells turned off. And then as I go up again above 800, the wells turn back on. Well, there's some other conditions I could use here to cause a shut-in. Perhaps when the static pressure is too high, we could also cause a shut-in. Let's add that now. I'll add my shut-in high pressure to be 3000 psi. I'm going to add an OR block to bring multiple conditions for resetting this block and turning off our sales valve. And I'm going to add an additional pin because I've got another condition I want to add after this. So this is my first condition. And then I also want to add now the high pressure. This is high level number 2. And let's write this application to our controller. Now we can monitor our shut-in conditions. We're currently running with the well open, and if we go low, as we know, if we go below 200, it shuts in, and then when it goes above 800, it reopens. Now, if we go above 3000, this is another shut-in condition. I'd like to add another condition, a low flow rate. So how would I look at the flow computer object for flow rate and use it as another condition for a well shut-in? Now the process inputs are already objects because they're currently wired to my analog input channels. But for the flow rate here, I'll need to get it by polling the Modbus register containing this value. All the Modbus registers are shown under the Telebus protocol, and for meter run 1, I can look for flow rate, and here's its register here. It's a floating point. So how am I going to do this using my logic program or my configuration to get at this register? Well, what we do is we use a Modbus scanner and we pull the address this internal IP address 10.2.3.4. Let me show you how that works. First of all, to use the Modbus client, I'll need to go offline and change the project settings to add this feature, Modbus IP client. Now under Modbus, I have Modbus client here. I'm going to add a device. In this case, I'm pulling myself, so I'm going to call it my flow computer. I'm going to use Modbus TCP, and I'm going to use that internal address. I need to change the Modbus byte order for 32-bit data to the one that Realflo uses. Apply that change, and now under the Modbus client, I see my flow computer device, and I can add a scanner. A scanner is simply a group of registers that are polled together. So the register I want from my help file is 47528, and it's a floating point. Now one register, in fact, when we're in floating point, we need to have an even number of registers. So this will be 2 to get my one floating point register. I leave these 0 to use the default scan rate and timeout defined for my device. I'm going to automatically create objects and leave their assignment to DMP or Modbus unassigned. So here's the name of my object, and I'm going to change this to be simply flow rate. Apply that change and write that to my controller. So these are also the objects created to monitor this Modbus scanner. We can look at these in a object browser. And these are conveniently already given the object group name of my flow computer. Here they all are here, including the flow rate registers the one I want, and it will be placed in this object. Refreshing this object browser automatically, we can check that the correct flow rate is being pulled. Now I do need to change the format for my flow rate to be floating point. So the value is 28.62. If we check in Realflo, the same value. So this is working. We can pull ourselves for any flow computer register and place it in an object. With an alert notification added to it. I do need to see it first, so I'll put it as a real value, and I want to look at its limit, so I need it to be an advanced analog. Apply that, and also set an alert notification. This will be a shut-in for when the flow rate is less than 20 MCF. Apply that change. We have a confirmation of a modification here, and now I can write this to my controller. In my logic program now, I'm going to look at the flow rate and if I go online, I should see my flow rate. There it is, 28.62. And now with the low alarm, I should see when this value goes below 20, I'll just lower my DP to get the flow rate to go lower, and then below 20, there's my low limit alarm. And going above 20, and it clears. So this will work if I add this right here in my OR block. Let me do that now. I'm going to do an online edit. Now, looking at my well, if I have a high pressure, remember I'll have a shut-in. If I have a low pressure, for static pressure, I'll have a shut-in. And now, if we have a low flow rate, looking at my flow rate below here, when it goes below 20, I'll also have a well shut-in. There it is. Now these limits can be tuned, of course, without having to change the program. We can do that from set points in the objects. For a low flow rate condition, notice that we're going to need some way of resetting the low flow rate condition with a reset switch at the sales valve. I've completed the program here adding a reset switch because when I have a low volume flow rate as a shut-in condition, Having an instantaneous increase in flow rate is not possible if it's already shut in, so we need to have a reset switch. So if I lower the flow rate in this example to the point where it causes a shut-in, I'm going to need to use a reset switch to reopen the sales valve and allow my volume to increase, my volumetric flow rate to increase so that the well will stay open. To use the same shut-in logic for the example where we were polling the MVT for the process inputs, it would look like this in Remote Connect. I would still poll my flow computer, but I would use two scanners, one for the flow rate and another for the MVT parameters of dP, temperature, and static pressure. These two values I'm not interested in, so I haven't given them any special object names. So when we have a large difference in register range to poll, I'll need to create multiple scanners like in this example. So depending on where you are polling in the Modbus database of flow computer registers, you'll need to add the appropriate number of scanners. You could also do this using Modbus function blocks to pull directly from the logic program. But sometimes the scanner is the simplest way to configure this.